So in multiplying square roots, it's important to remember that if we have the square root of some number, a being the radicand, times the square root of another number, b being also a radicand, then the position says that we are going to be able to multiply both of them underneath the same radical. Okay? So here we have the square root of 2 times the square root of 6. So that would be the same thing as the square root of 6 times 2, which equals the square root of 12. Now, since 12 is not prime, we know that we're going to have to go ahead and simplify this. So if we break this up, we can go ahead and do one of two routes with this. We can go ahead and we know since 12 is not does not have a perfect square, then we're going to have a radical sign. And if we factored this, we'd get 4 and 3 and 2 and 2. So since we have this pair of 2's right here, we can go ahead and move it to the outside of the radical, and we're left with this 1, 3 that we will leave underneath. Now again, I also want you to keep in mind and remember that the square root of 12, by using this rule right here, is the same thing as saying the square root of 4 times the square root of 3. And we know that the square root of 4 does in fact have a perfect square, which is 2. So we have 2 square root 3, which is in fact the same answer that we had over here. Okay, so let's go ahead and do this. Now, initially, it seems like this is going to be a pretty big number, but we shouldn't have much of a problem once we get finished up with looking at it. So we go ahead and multiply our radicands under the same radical. So we have 15 times 6, which equals the square root of 90. Now, we can go back to the factor tree, but we're going to go ahead and start moving on from this position. We need to start thinking about how we're going to multiply this using perfect squares. So I do know that the square root of 90 is the same thing as the square root of 9 times the square root of 10. Okay, and we know that the square root of 9 is in fact equal to 3, so 3 square root 10. Okay, so let's look at this one right here. We have the square root of 3 times the square root of 10. Okay, so we bring both of our radicands under the radical, and we are in fact left with the square root of 30. Okay, now this one, if we try to think about, okay, what do I have that might be a perfect square that I can multiply this with, this doesn't seem to be as intuitive for us. So let's go ahead and look at 30 in a factor tree. Okay, so we have a 15 and a 2, okay, and then we have a 3 and a 5. Well, now that I have used prime factorization and reduced this to the primes, I see that I do not have any pairs of numbers. So in fact, this is our simplified answer. We can't go any further than that right there. Okay. So when we look at the square root of the same number under the radical, we can also follow a rule that says that if I have the square root of a times the square root of a, that will in fact equal a. Our radicals will cancel out. So in this situation right here, we have the square root of 8 times the square root of 8, and so by using this rule right here, we can know that this is just going to equal 8. If we worked it out, we would take the two radicands, multiply them together, 8 times 8, which equals the square root of 64, and we might remember that the square root of 64 is in fact 8. Okay, so We're going to move on. Square root of 3 times square root of 12. All right. So let's look at this. So take our two radicals, or radicands, I'm sorry, put them under the radicals. So I have the square root of 36, which is equal to the square root of 9 times the square, I'm sorry, there's a pretty provocative piece to that, excuse me. Let's see. I even went a little bit further in my own steps there, and realizing that the square root of 36 does in fact have a perfect square to it, and that's going to be 6. I was actually moving forward to saying, okay, well, the square root of 36 is the same thing as the square root of 9 times the square root of 4, but we see both of these are perfect squares. 3 times 2, which equals 6. That's our answer. Okay. Now we have something a little bit different because we have coefficients that are out here in front of the radical. Okay, so we've got to go ahead and multiply this at two different levels. So here, we're going to multiply our coefficients that are out here in front of the radicals. So we have this negative 3 times 4. And then we're also going to multiply our radicands. 2 times 8. So now we're left with negative 12 square root 16. And you might realize that, okay, well, square root of 16 has a perfect square of 4. So we have negative 12 times 4, which equals negative 48. Okay. Again, using our rule from before, if we have the same radicand, when we multiply them together, we will get 5. All right, number 8. Again, remember that our coefficient out here is going to be a 1. All right, so we have 1 times the square root of, 1 times negative 4. And then we multiply our radicands, 2 times 5. So we get negative 4 square root 10. And this cannot be reduced. Alright, this one we're actually using the distributive property. So we're distributing this to each one of these terms. So we have negative 2 square root 15 times square root 5 plus negative 2 square root 15 times square root 6. Okay, so let's deal with this first part here. Okay, so the 15, we have negative 2 15 times 5, and then we have a minus 2 square root 15 times 6. So this is going to give me a negative 2 square root 75 and a minus 2, and this is going to give me a square root of 90. These still are not simplified yet. Let's take this first part here and work on it. So we have a negative 2, and this square root 75 right here can be broken down to the square root of 25 times the square root of 3. The square root of 25 is going to be 5 times negative 2 square root 3. So we get a negative 10 square root 3. Alright. Working on this 2 square root 30, again keeping our negative sign all the way down with us. The square root of 90 can be reduced to the square root of 9 times the square root of 10. Square root of 9 is 3 times 2 times the square root of 10, which is going to be 6 square root 10. And here we have our solution. Okay. And the last problem, number 10, same thing, distribute. This is a little bit easier. Alright, we have the square root of 2 times the square root of 5 plus the square root of 2 times 5. Okay, so the square root of 2 times the square root of 5 is the square root of 10, plus 5 times the square root of 2 is just that, 5 square root 2. And that would be your answer.